Okay, 2-2, we are determining unit rates with ratios of fractions. So we're still doing unit rates, but we're gonna be dealing with some fractions today and decimals. Okay, Allison and her classmates planted bean seeds at the same time as Yuki and her classmates in Tokyo did. Allison is video chatting with Yuki about their class seedlings. Assume that both plants will continue to grow at the same rate. Who should expect to have the taller plant at the end of the school year? Okay, so it's saying that Allison's class is 2.5 inches in 5 days, and then Yuki's class is 5.5 centimeters in 4 days. Now we have a bit of an issue here. The issue is that this is in inches and this is in centimeters. So we're going to get everything to inches. So this is already in inches, so this is good. So we can easily calculate this unit rate. So Allison is 2.5 over 5, right? Inches over days. I'm going to divide by 5 to get my unit rate here. 0.5, okay, over 1, so that's 0.5 inches per day. Now we have to do Yuki, so we can't just do 5.5 divided by 4 because this is in centimeters right now. So we're going to convert centimeters to inches, and we're going to do that by doing 5.5 centimeters divided by 2.54 centimeters equals 2.17 inches. The reason we're doing that is because there's 2.54 centimeters in every single inch. You might remember that conversion, you might not, but there is 2.5 centimeters in every inch. So we need to figure out how many inches this is. So we're doing 5.5 divided by 2.4, that's 2.17 inches. Now we can convert it. So we have 2.17, I'm going to cross this out, 2.17 inches in 4 days. 2.17 inches in 4 days. Divide by 4, divide by 4. That means that it is 0.5425. So 0.5425 inches per day. So they're close. But we can see that Yuki should have the taller plant because her plant grows at a faster rate. Because this number is bigger than this number. Okay. Focus on math practices. What must the students do before they can compare the heights of the plants? We first needed to convert Yuki's plants to inches. So you need to first convert Yuki's plant to inches. All right. Example 1. Sure we're all focused. Okay. Sergio is training for a marathon. His target speed is 25 miles per hour. Did he achieve his target speed for the first 7 miles of his ride? Okay, so it's saying that he's traveling 7 miles in 15 minutes. So this is really another conversion because we have per hour here. So we need to convert minutes to hours. Now 15 minutes is a fourth of an hour because there's 60 minutes in 1 hour. So 15 minutes goes into 60 4 times, right? So if I put 15 over 60, right? 15 minutes over 60 minutes, that would reduce to 1/4. Okay, so we did our conversion there. So we can say, I'm going to make a little chart here, miles, hours, okay, so he's traveling 7 miles in a fourth of an hour, okay, because 15 minutes is a fourth of an hour. So now, if we need to get this to 1 hour, because we need to figure out how fast he's traveling per hour, if I need to get 1/4 to 1, I'm going to multiply by 4, because a fourth times 4 is 1 hour. If I multiply the bottom by 4 here, I have to multiply the top by 4, multiply. 7 times 4 is 28. So he's traveling 28 miles per hour. and his target speed is 25 miles per hour, so he's going faster than his target speed. So yes, because he is traveling 28 miles per hour, which is faster than 25 miles per hour. Okay, now you're going to do the try it. This one's a little bit backwards, so this one, it gives you, his target speed is 30 miles per hour, and how many more miles does Sergio need to ride in 1/4 of an hour? So instead of multiplying, you're actually going backwards and you're dividing by 4, divide by 4. So do the try it, pause the video, make sure you get the same answer. Divide by 4, 7.5. So Sergio must ride 7.5 miles in a 1/4 hour to achieve his target speed. He needs to ride an additional blank miles per 1/4 hour. So here we have 7.5 miles in a 1/4 hour. Here we have 7 miles in a 1/4 hour. So he needs to ride an additional 0.5 miles, okay, because 7.5, that's 0.5 more than 7. Example 2. All right. Bronwyn mows the lawn every other weekend. She can mow 12,000 feet squared in 2/3 hour. The lawn is 36,000 feet squared. How long does it take her to mow the entire lawn? Okay, so we're going to find our unit rate first. We're going to figure out how many feet he mows per hour. So to do that, we're doing 12,000 divided by 2/3. You don't have to write it this way if you don't want to. I'm just getting you comfortable with complex fractions as well as this form. 12,000 divided by 2/3. We are going to keep, change, flip, as we've learned. I'm going to put 12,000 over 1, so it's a little bit easier. I can cross simplify here. 2 goes into 2 once. 2 goes into 12,000 6,000 times. 6,000 times 3 is 18,000, and that is feet squared per hour. So that's what he's mowing per hour. So now if the lawn is 36,000 feet squared, how long does it take? Well, we need to divide 36,000 divided by 18,000, and that's going to get you 2 hours. Okay, do the try it now, and then pause the video and come back and see if you got the right answer. Okay, so this one we're doing 15,000 divided by 3/4. So 15,000, I'm going to write it this way now, divided by 3/4. So that's 15,000 over 1 times 4/3, keep, change, flip. And cross simplify. 3 goes into 3 once. 3 goes into 15,000 5,000 times. 5,000 times 4 is 20,000 feet squared per hour. Okay, so who mows the lawn in less time? So if Daniel is mowing, this is Daniel, if he's mowing 20,000 feet squared per hour, and then Bronwyn is only mowing 18,000 feet squared per hour, it would be Daniel, because he is mowing more square feet per hour. All right, last but not least, example 3. Solve problems using unit rates. So Omar knows that his friend Chris lives 3/5 miles away. How far is the school from his house? Okay, so if Omar knows that his friend lives 3/5 miles away. Okay, so Omar knows that his friend Chris lives 3/5 miles away. So this is 3/5 miles. It's also 3/4 inch, because this is like a scale. You know, on a map, like how they make a scale, like 1 inch is actually 1 mile or something like that. So this is our scale. So what we're going to need to do is we're going to need to divide this out to find out miles it is per inch. So 3/5 miles over 3/4 inches is what we're doing. So that's 3/5 divided by 3/4. That's 3/5 times 4/3. I can cross simplify. 3 goes into 3 once, 3 goes into 3 once. 4/5 miles per inch. Okay, so now it says how far is the school from his house? So school to Omar's house, so it's 2 inches. So if it's 4/5 miles per inch, what we need to do is we need to do 4/5 times 2/1, because it's 2 inches. And that gets you 8/5, which you can convert into a mixed fraction. 5 goes into 8 once, with 3 left over. So 1 3/5 miles. Okay, do the try it and then come back and see if you got the right answer. Sonoma bikes 5 miles to Paige's house. On a map, they measure that distance as 5-6 centimeters. The same map shows that the mall is 3.5 centimeters from Paige's house. What is the actual distance between Paige's house and the mall? What we're going to do first, so we're going to find our unit rate, 5 divided by 5/6. 5 divided by 5/6. That's 5/1 divided by 5/6, which is 5/1 times 6/5. We're going to cross simplify. 5 goes into 5 once, 5 goes into 5 once. That's 6 miles per centimeter. So if it's 6 miles per centimeter and the same map shows the mall is 3.5 centimeters from Paige's house, we're going to do 6 times 3.5. Okay, so 6/1 times, I'm going to convert this to improper. 2 times 3 is 6, plus 1 is 7/2. Cross simplify. 2 goes into 2 once. 2 goes into 6 3 times. 3 times 7, 21 miles. Okay, I'd like you to now do the do you know how questions, and then I will post a picture of the answers of that so you can check your work. Then you'll do practice and problem solving. You'll just do that first page again, and I'll post the answers to that tomorrow, but that is the work that you need to submit to me. All right, have a good day.